In part C, we have 15 minus 2x minus x squared. Is there an easy way to factor something out so I have a 1 in front of the x squared instead of a minus 1? Does everybody see I could factor out a negative? Really, what am I factoring out when I factor out a negative? A negative 1. But we think of it as factoring out a negative. And then how does that change? What would this look like then? On the inside, all the signs would change, right? It'd be negative 15 plus 2x plus x squared. Does everybody see that? Okay, now I'm going to reverse the order of the addition here. That's the commutative property of addition. We can reverse the order all day long. And I'm going to rewrite this as x squared, descending powers of x. X squared, what would it be? What else? Plus 2x minus 15. Now, on the inside at least, we have a polynomial of the form x squared plus bx plus c. So a is 1, in other words. And then we can use that systematic method to factor this thing. Don't forget to leave the negative on the outside. So I'm going to leave a minus here and then set up my 2 parentheses. And you want to find two numbers whose product is what? Not 15, but negative 15. Two numbers whose product is negative 15 and whose sum is positive 2. So I do that too. I get the numbers first, and then I know one of them's got to be negative. How do I know? Because the product, remember, when you multiply the last term, whatever that is, times the last term, you get a negative 15. That means one of those two numbers we're going to put in the box is negative, right? So we know one of them's negative. Actually, I'm going to erase the box. We know one of the last multipliers is negative, and I do that too. I get, set up the x and x first, and then for the last terms, I kind of ignore the negative. This is the way my brain works. You can do it however you want. But I know one of them's got to be negative, but I kind of ignore it. And then I write down the 3 and the 5, and I think, is there a way I can put in a negative so that when I add those together, I get a 2? Absolutely. Which one has to be minus? Minus 3 plus 5. So negative 3 times 5 makes a negative 15. Negative 3 plus 5 makes a positive 2. Can you check your answer on these? You could multiply it back out, right? Don't forget to distribute the negative after you multiply it out. And then you'll get exactly what you started with. Up to ordering, right? It'll be in reverse order of what you started with. Okay? Now, can you think of another? So this answer is an answer. But when you look up your answers at the end of the book, when you're doing the homework, you've got to be aware they might write it slightly differently. I'll give you an example of an equivalent answer, and you tell me how I got it. The quantity 3 minus x, that's supposed to be a minus x, times x plus 5. I claim that that's an equivalent answer. How did I get it? Yeah, if you distribute the negative on this first guy, you get a minus x there and a plus 3 there. And then what did I do? I just reversed the order. It's negative x plus 3 is the same as 3 minus x. So be aware that you can do little things like distribute a negative, commutative law of addition, switch the addition around, and it'll look a little different. You might think you have the wrong answer when you don't. Okay? So either answer is acceptable. Yes?
In the beginning, when you switch everything, can you just do put it in the right order?
Yeah, and you could do that, and you could just factor it as is. So another way to go here is you could have just left it in the order that it's in and think, okay, what are two numbers that multiply together to make 15? Maybe like 3 and 5, like that, right? And then, okay, to get a minus x squared, what could you do? Well, you could experiment. Maybe this won't be right, but you could put a minus. Well, actually, it will be right. So let me do one that's wrong. You could put a plus here and a minus here, because you know that The last guys, when you multiply them, have to be minus x squared. So you could try this, but then very quickly you're going to see it's not going to work, because if you multiply out the outer and inner multipliers, so you get a negative 3x and a plus 5x, right? Which is a plus 2x. So you got the minus wrong. So you could switch it around. It's a little bit of trial and error. And oh, lo and behold, you get the same alternate answer we had that I mentioned previously. So you can reverse FOIL it as is in this case. But I just kind of like it when there's a positive 1 in front of the x squared. I just think it's more systematic that way. So that's the reason for the way I presented it. All right, what else have I got for you? Oh, 2 unknowns. Part D, we have m squared minus 2mn minus 63n squared. Well, a slight adjustment here, and the method I just mentioned will still work. Notice that there is a 1, and if you consider m the unknown here, pretend like n's not there for a second, there's still a 1 in front of the m squared, right? So let's try reversing the FOIL and maybe throwing in a couple of extra factors of n to get it to work. So let's put in a couple parentheses. Think of the FOIL acronym, first, outer, inner, last. The F stands for the first multipliers, right, from both binomials. So what would they have to be to get m squared? M and m. And then think about the last multipliers from both binomials. They'd have to both contain a factor of n, wouldn't they? So maybe an n here and an n here. Now, we're going to need a blank to fill in. So let's put a blank in front of the n's. So this is the slight adjustment you have to make. If you just throw in a factor of n on both of the last multipliers and then factor it as usual, it'll work the same way. So now that the n's are there, just look at the negative 63, find two numbers whose product is negative 63 and whose sum is negative 2. Okay, one of them's got to be negative, right? To get that negative 63 n squared in the end. So you know one of them's negative, but forget about that. Think about two numbers whose product is 63 that have a difference of 2. Just for a second, forget about the negatives. 7 and 9. Okay, so you fill in the blank, 7 and 9. Now, to get a negative 2, the sum of these two numbers here and here have to be negative 2. One of them's got to be minus, but to get a negative 2, which one has to be minus? The 9. So minus there, plus there. And let me delete that blank because it looks weird. And that'll do it. So it becomes m plus 7n times m minus 9n. Can you check it? Yeah, I haven't checked any of them, so let's check this one. Let's FOIL it out. First, outer, inner, last. What do you get when you multiply out the first? So this is the answer. We're checking it. What do you get when you multiply out the first terms? So you get m squared, first times first, m squared. The outer? Minus 9 times m times n. The inner? Plus 7m times n if you reorder the multiplication. And the last? Minus 63 times the n squared. Notice that these middle terms do, in fact, add together to be negative 2mn. And so it looks like we're getting the same thing as what we started with. So big old check mark right there. But remember, it's this guy that's the answer. That multiplying it out was just checking it. So factoring is the reverse of multiplying, right? So it makes sense you could check your answer by multiplying it out.